Welcome in the first section of our course. In this section, we'll be looking at the functional operators that are available in reactive programming. So at the beginning, we'll be extracting needed values using tuples. Next, we'll be using map with the functional flow. Next, we will do fold. So fold is also implemented sometimes as the collect, depending on the library, and it is used to aggregate results from reactive flow. We'll be doing it as well. Fourth video will be about the reduce, so we'll be calculating values on non-empty stream, and finally we'll be grouping events using group by operator. And this is a first video in which we'll be adding the ability to carry the value alongside with the transformation. At the beginning we'll be using tuple par abstraction, we'll be adding it to our project, we'll be plugging it into RxJava, and we'll be testing it together with reactive flow. So we'll be using a par object. Par is available on the org Apache Commons. To have it in your project, you need to create the dependency to Commons lang free, and this is the newest dependency, so you can update it as you wish. So once you will have that, you will have a par abstraction. But let's start from the beginning. So in this text, we will be creating the list of modifications. There will be add, redo, divide, copy. So we have 4 modifications. Then you are using observable and you are creating observable from our list of modifications, so we are creating it from iterable. At this point, it will create an observable of 4 string elements. But it is not everything that we need. Then we need to flat map, so we want to execute some specific action on every element, and we want that element to be in the result. So let's see what flat map will be doing. So we have data here, so data is a string, of course, so let's see the parameter. We can see that data1 is a string, and then we have method that change data. So we have some hypothetical value. So we can see that this method is just creating from array, and it returns the observable. So that's why we need to use flat map. We are using flat map to flattening that. We will be looking at this more in the next section, but let's stick to that. The most important thing is that it returns only the length. So we are mapping the actual string to length. So this is our result. So our result will be the object in this example, but sometimes in our processing we want to carry the original value. So the original value, original object is add, and derived value, that is after calling that function, is free. So per allows us to encapsulate both things. So our per we have data, so will be add, redo, divide, and so on, and actual object that is a result of the transformation. So then we can block first, so it will wait for the first result from this stream of events, and it will just return the par of string and integer. Then we can see that we can assert that par is equal to 3. So we have both elements left and right, so the original value and the derived value that is called to length function. So we can see that we are able to carry that. Let's start the test. Our test passed, but in the real world you will have further transformations, and sometimes here, for example, you want to map something, but still you want to have the original value. So you can do it using the par or tuple depending on the language in which you are writing your code. For example, in Scala you will have tuple.